Hi, this is Mr. Max with another video, and this time I'm doing transformation of functions. Again, as I said, you can find this on page 121 and 122 in the y equals mx plus c book for learners doing the AS level. Of course, you can follow in your textbook as I am just trying to explain the transformation of functions, things like vertical movements, horizontal movements, up or down, a stretch or a compression, things like that. Okay, so we start off by using various uh, type of software. So one of the software, and it's quite a free software that you can download. It's GeoGebra. Um, it just allows you to draw the graphs so for you to have an understanding. Okay, so I'll be using GeoGebra throughout this presentation um, to do the various functions. Okay, so the first one is you have got a function y equals f of x, and then you are adding something or subtracting something, some number there. Okay, this is now when you have an up or down movement. So the graph that you're seeing here, the one in black, so the one in black is the graph of, let's say, y equals to x squared, and the one in red is the graph, the same graph, but now it has been translated two places up from the origin. Okay, and then also the one in green is the same graph that has been translated just downwards. So this is y equals to x squared minus 3, because you can see it moved three places from the x-axis. Right. So it's very important that you do understand the vector that we are talking about. Of course, the 0 is the x direction, so this particular graph did not move to the left or to the right. It's just an up or down movements of the function. Okay, so just so you can see, if one has to put it up there for the software, so I'll go here and then I will just type the graph y equals to x squared. So this is the graph that I'm talking about. Okay, so um, again, I can label it, uh, or I can decide um, to just, let me go to the settings and then I name the graph, the value of the graph. Okay, so this is the graph y equals to x squared, as you can see. Now, if you input and we want to say y equals to, well, x squared, and then we say plus 2, let's say we add 2, then you will see that the graph sort of is translated upwards. Okay, it's translated upwards, and let me just rename it so you can see it, so you have an idea of how these particular graphs um, move. Maybe you can also play around with the color. Okay, so there you have it. So now you have got y equals x squared plus 2. The whole graph has been translated up. Okay, translated up by 2. So again, if we were to do the same thing, we say y equals to x squared, and then we say minus 3, then we are now talking about a downward translation of the graph. Okay, right, so this one I'll probably make it green, and we'll also have to perhaps give the value of that graph. Okay, so for you to have an idea, so this is the the graphs that you see in our first particular translation. Uh, that is, remember, these graphs, they will never actually meet. They get closer and closer to each other. It's just how the graphs are being translated upwards, So if c is a positive number, so the function plus 2 goes up by 2. So the function minus 3, the graph is then translated downwards. Okay, and that is what this here refers to. Okay, so when you have this condition here, that if c is a number greater than 0, obviously it's 0, it's just going to be there. So that constant c, if it's greater than 0, positive number, then the graph moves up by that number of places. If it's a negative number or less than 0, the graph goes down by that value of c. All right. The second type of transformation that we are going to discuss, so you have got y equals to f of x, that's the function. And then inside here now we are going to talk about the graph moving from left to right. And you have to be a bit careful because by now you should know how to sketch parabolas. Okay, and the original function is here, this one, y equals to x squared. Now, what you also need to understand here is the red one. Can you see that it moves places? So that is y equals to, in bracket, you're going to have x square, and then obviously, let me just clean that up so that we can bring in the right color. So let's have that as a red. So that is y equals to, in brackets, so you have got x minus 2 all squared. So what happens is here, which is what you need to understand, is that as the stuff inside the bracket there, if this stuff inside the bracket is a negative, like x minus 2, then the graph is translated. It's translated to the right side. So opposite, minus here, the graph goes to the left or to the right. So if the stuff inside the bracket is a positive stuff, so you have got the function y equals to x minus 3 all square, then you can see that the graph is translated to the left, to the left. This is supposed to be x plus 3. Okay, so that's a positive value. The whole graph is going to the left. So it's very important that you understand that and also understand the relationship between when you're dealing with that. So I always say the stuff in there. I always say the stuff in there plays a key role whenever you are, even if you were supposed to do when you're supposed to do um, vertex form. So I wrote stuff squared equals to 0. So let's consider the stuff. So in this particular case, the stuff x plus 3. So if I take x plus 3 and I say x plus 3 and I let that equal to 0, then you'll see that the x equals to negative 3. That is going to be the place where this graph is going to be translated to. So that will be the line of symmetry of that particular graph. Okay, so that is one of the things you should do. So again, it's a vector. The on top, the vector, because remember with vectors you have got x direction and y direction. So y is 0 because it doesn't go up or down, so that's why you see that these are zeros. The values of a is by how much the graph is moving. Okay, so it is then that particular vector that we are referring to. Okay, so let me then also bring it up then into the software so that you can follow. So we have got the same graph, but here we are going to make some changes. All right, so we're going to make some changes. So we're going to have a bracket here, and then we're going to have here plus 2, okay, or should I say minus 2, rather, minus 2, and goodness, here is where I want the bracket to be. So just give me time. Okay, and then I raise the whole thing to the power of 2. Okay, now you will see that the red graph has sort of moved to the right, so that is negative. So let me come to this one, and I'm going to make changes as well. So this is going to be x plus 3 all squared. So you will see that the green graph is going to be now to the left. So if there's a plus, the green graph goes that many places. Okay, so this is what I hope you understand once we're dealing with that second function. So we're now talking about the horizontal translation of the functions. Okay, could be any function for that matter. All right, so let's look at our third scenario. Again, we have got a graph here. Now, this particular graph is it's the third one. So here now we are talking about the reflection. Now we're going to do two types. We're going to do the reflection in the x-axis and we're going to do the reflection in the y-axis. Okay. So if you put a minus the whole function, so you have got a function and you multiply the whole function by a negative value, right? A whole function by a negative value. It means that that whole graph will be flipped upside down by that whole -1 by multiplying the whole function by -1. So whatever the function, and let's suppose this one here is the function y equals to root x. Now, if I take that same function, but I just put a minus in front of it, so I have y equals to minus root x. So the graph will be sort of flipped, okay, where the x-axis becomes the line of symmetry, and it has to be a function, okay? It cannot go the whole way. So I hope you understand that. So whatever function you are given, all right, and you have a negative in front of that function, the function will flip. So I will be typing in that function, but I also use our function that we have from before. So we have got that particular function. So I'm going to put that function and I'm going to put a negative in front of that function. So I'm just going to change this function here. I'm just going to change it. So we're going to have maybe the whole function, remove the bracket. So I've got a negative, and then I put and a whole x squared in front. So that's the function, and you will see that the graph has been flipped. Okay, can you see that? It has been flipped about the x-axis. Okay, so when you have a negative in front of a whole function, that is what you're going to have. So let's look at the one that we have that we are using. So if I give you another function and the function is y equals to, now I'm going to find the square root of x, so square root of x, okay. So here's the function that you have also from your textbook. So this is a function here, okay. I can do this, just label it properly so you can see. So that's the value, y equals to square root of x, okay, name and value. So that could be the function, right? So now if I put a whole minus in front of that function, so I will say y equals to, I just press y, then I put the square root of negative, well, I'm just going to put this in bracket, doesn't really matter for this case. Let me see. So I'm going to have square root of that. So you will see that now it has been reflected. Can you see that? It has been reflected. So let's just remove that labeling there, and let's put our label. So I'm going to say name and value. Okay, good. So the function is now the reflection. Can you see that of that with the minus in front of the function? So the whole function has now been sort of reflected about the x-axis. So no matter what type of function you have, the moment you put a minus in front of the function, then the function is being reflected in the x-axis. Okay, the whole function, all right, is reflection in the x-axis. I hope that you get those ones. Huh? These ones are pretty much straightforward for now. All right, that brings us to reflection in the y-axis. So we'll take the same function, okay, the same function, the function here, which is y equals to the positive root of x. So if we are now reflecting it, okay, this is what I need you to understand. So we multiply every x value, no matter the function, every x value of that function will be multiplied by negative. So if you have this one here, let's just change the color. Let's suppose, so this is going to be y equals to, right, minus x. But remember, every x value should now be multiplied by that. So if you have a table of value, all right, so I have a table of value, and I say I want to put this one in. So I'm gonna say, let's say y here, uh, and x here. So if x is -1, if x is let's say -4, for example, what would be the output? Okay, if you put -1 in here, so that's going to be y equals to negative and then -1 here, you're going to get the square root of 1, which is 1. That is why you see the point, it's up there. Okay, so if I was to do something similar, y equals to square root of negative, and I choose -4. Well, that's the square root of 4, which is nothing but 2. And you can see that the corresponding y value is 2. And you're going to get the same answers if the values of x are positive. So if you have your x and your y here, and you choose again 1, and I choose again 4. And if I was to put y equals to the square root, now x is 1, well, the answer is just 1. That's why you can see it's up there. And y equals to the square root of 4, this input here. So if it's 1, it's 1. If it's 4, square root of 4 is 2. And that's why you have that particular value. So these are, if every x value of your function, if you multiply it by a -1, then the function will be a reflection on the y-axis. Very important you understand that. So let's quickly bring that into play. So I'm going to do the same here. So maybe I should bring that back, and then I can do the changes. Let's see if I just put an x there, what it does. Maybe perhaps I put this in bracket, and I put a I remove this minus here. See what it says. There you go. So you see now this is a reflection about the y-axis. One, every value of x is negative. Remember, not a negative value in here. So if you have a negative, multiply the value of x by -1, and negative times the negative will be positive. That's why you have the same inputs. Okay, even if you were to test this one, so if I uncheck this one and I bring back our original one, y equals to x squared, and I come to this one, now we said every value of x should be multiplied by negative. Okay, negative. So let me just change this, and then I have the function square there, and you would see. So if I was now to do it, um, every value of x should be multiplied by a negative, but remember the x values here can also be negative. So let's see what the function, in fact it will give me the same, let's see, let's check it out. It's going to give you the same sort of value. It's going to be, remember we said the whole thing should be reflected. So this one won't work because you have now sort of two functions on top of each other, because that is the function, and talk about the reflection on the y-axis, the whole thing will just be on top of each other. That's why we're using this particular one for these questions, okay, where there's that restriction on the domain. And I hope you do understand when I talk about the restriction on the domain. The next one, this is now the part where we are talking about the stretching and compressing of a function. So here you have got, and it's very important that you understand, so stretch and shear, or let's just skip and say, so you have got a function here, let's make it in the black color, the function here in black. So the function here in black is the function y equals to x cubed minus 4x. Okay, you got that? So let's go back to our table there, and we're going to put in that function. So we're going to put a function y equals to x cubed minus 4x. So this is the function that we are now talking about. Okay, can go ahead and we can also label it properly if that is the case. So I'm going to label it so it's just bringing that. Okay, so that's the function. Let's change the color to black. Okay, so this is my function that I'm now referring to, the function y equals to x cubed minus 4x. So this is the once you are now doing something here, and this is what I need you to understand. If we were to put in front of this function some number, okay, so in front of this function we put some number, and it's going to stretch the function. If the number that we're going to put, if the number is greater than 1, like a 2, and I'll look at that now. If it's greater than 1, it's going to stretch the function. So where you see the black one is now, it's being stretched. Can you see where the red one is? It's being stretched, but it's still, it's a vertical stretch. So it's a stretch in the y direction, in the vertical direction. If the number in front here, so the one in red, and let me just write it down. So the one in red is y equals to, so that's a 2 because it's been stretched. So that will be a 2 in front of the whole function. Okay, that will be 2, and then you have got x cubed minus 4x. So the one in red, can you see the vertical stretch that we are referring to? The vertical stretch in the y direction. So if this number here, this c, this number, if it's a number greater than 1, okay, in this particular case it's just 1, so if number greater than 1, you have got a vertical stretch. I hope that makes sense. If, however, that number is a fraction, a number between 0 and 1, then it's being compressed. So it means then you can see your one in purple. So from black, it's being compressed, but it still doesn't move to the left, to the right. It's just the vertical sort of stretch or compression that happens. So the one in purple, okay, I'll just use this color. It's very close unless I'm colorblind. So one in purple will then be y equals to a half of that x cubed minus 4x, because you can see this one now, it's the one that is being compressed, and this one in red is the one that is being stretched. So this one is the one that is being stretched. Okay, so that is what, if you put a number in front of the function. So let's just go back to my function, and I'm going to do the same. So we're going to input our function. We're going to say y equals to, then I put a 2 in bracket. I have got x cube minus 4x. There you go. All right. So this one is in red or some weird color there, but you'll see because of that 2, it has been from where the original one is. The original one was at y equals -3. Now it's 2 places, right? So is it? Yeah. Okay. Well, in any case, can you see the stretch, the vertical stretch about the y axis? Okay. So the one in that's the one in black. So let's just label this one properly so that it can make perfect sense for you. So I'm going to choose red for the color first of all, and then I'm going to go and say okay, value and name and value. All right, there we go. So good. So the one in red is now identifying um, that particular case. All right. So the one in red, we have a 2, right? So it then stretches the whole thing, all right, in the y direction. Stretch. Obviously the compression. So we're gonna have y equals to. So let's put a fraction 1/2 in bracket. We have got no. Let's be careful when you use this type of software that you understand them. Maybe you will also get and see how I use them as I go along. So that's x cubed and minus 4x. All right, so this one is obviously, can you see that purplish thing that I said? So let's just put um, the name, the value. Good. Well, this purple is under, red is here, purple is here. Well, can't move it much, but you get the idea. Um, Again, if I was to perhaps move them along, the black one is there, the red one is there and the purple one. Can you see the purple one? Because of the minus half. Right, so that is with regard to what happens when we talk about a stretch. The stretch is the whole function multiplied by some number. And if that number is greater than 1, then it's a stretch. If you take the whole function and you multiply it by a fraction, it's a compression. Okay, it's a compression. All right, about the y direction. So it is the vertical stretch or vertical compression if you are dealing with that. Okay, so that takes us to our last one. And our last one is obviously if you have a vertical stretch, you also have to have a direction in the x direction, a stretch or a compression in the x direction. So if you look at, let's bring in the black one. So the black one again, it's our function y equals to x cube minus 4x. Okay, so let's just bring that. So it's again that same one that I'm talking about. You get it? All right. So if we now do things to the function, and this is important that you understand. So let's first have the red. So if we look at the red, so what appears here at the red is that you are now multiplying, because here the compression in here, you must not be careful. So if we say we take in front of our where we have our x, but now we have 2x cubed minus 4 times 2x, for example. You can see it's like where you had an x, right? Now there is a 2x there. So when that happens, all right, that is where we are now talking about this. Let me just so you can see that 2 is greater than 1. Can you see that? It's greater than 1. So the graph is from the black, it compresses in the x direction. I hope you understand that. It compresses in the x direction, and it is sort of getting, I don't know, narrower and narrower, but it's in the x direction that you now have. If, for example, and that's the green one that I'm going to bring out now. So if, for example, we have the same function, but now I'm putting in a half in front of that x cube, or that x, so I'm going to have 4 times the half of x. Now you realize that this here is a fraction in front. If it's a fraction in front, that's what we mean by if that number is a number between 1 and 0, or a stretch vector of 1 over c, which is a fraction, then it stretches. It sort of goes, it stretches in the x direction. Can you see that? It sort of opens up in the x direction. Can you see what happened to the green one there? That's what we mean by that particular stretch there. So don't get confused between the stretching in the y direction, which is slightly different. Okay, when you are doing when this is greater than, then it stretches when, and I'm not talking about this value here. So please don't get confused. It's sort of the other way around. So think of the bigger this number is that you are dealing with, all right, the smaller or the steeper the graph becomes, kind of that, like a gradient, and it's becoming steeper and steeper. Okay, so let's put it into practice. So we have that function. So we're going to put the same function. We're going to just say we're going to put a 2x, and that is cube minus 4, and then obviously here I said 2x. Okay, so you might see what I'm referring to. Because of that 2, you have got a compression. So we can, let's see if we can play around with this. Just change the color to red, and also if I can just name the value. Okay, so that is what happens there. So when you have a 2, you have got that compression. Okay, don't forget. Greater than 1, you have a compression. Can you see that? Greater than 1, you have a compression. If it's a fraction, it is a stretch. All right, let's so put it in when it's a fraction. So let's put another value, and we're going to say y equals to, so let's use 1 over 2 of x, okay, raised to the power of 3 minus, let's just come down here so you can see what I'm doing. Okay, where am I? I'm here. Let me just create some space here. So minus, and then I have 4, but then multiplied by 1 over 2 of x. Good. There you go. All right, so let's just bring it to the color I want. So again, I'm going to remove that label. I want to label it myself. Settings, I'm going to have the name value, and I'm going to make it green. Okay, so there you have. So you see the one in green, it's stretched. So the moment that green stuff, the moment in green, you have got a fraction. Okay, the moment you have got a fraction, then obviously you're now talking about a stretch, sort of stretches in opposite direction. So again, if you add numbers in front of the value of x in your function, then your function is now stretching about the x direction. Okay, if you are multiplying the whole function with some number here, then we are now talking about a stretch or a compression about the y direction. Okay, so this is in a nutshell when it comes to transformation of functions. And remember, these are not the only functions. These are just basic functions that I've introduced here. You're going to have a lot more functions in a lot more topics. So you're going to do trigonometry. You're going to have trig functions there. Then the same concept applies. You're going to have logarithms or logarithms. You're going to have logarithmic functions and so on. So you're going to have to remember the transformation of functions once you come across doing functions of those various type of topics. Okay, and also your knowledge of domain and range comes into play, and asymptotes. So please, the topic on graphs and functions is there to give you a sort of an overview of what is coming as you're doing the topics as you go along. All right, so this is Mr. Max. I hope this was very useful, and then you can use this information to help you with your studies. Good luck. And one more thing, please don't forget to support our channel. Okay, it's a lot of work for me to do this, right? So it means sometimes you need to have um, that input from various people. I do put in the link. You'll see my email um, address, and you can send questions. And also, if you want to make the channel better, give me ideas. All right, even financial contributions, may I say? Well, just talk to me, because the more there are queries, the more people want me to explain things, then I'll find time to do so.